Hey everyone, welcome back. In Module 2, we'll go over how to calculate schedules, including the start and end times of activities and the overall project timeline. In this video, we will start with Lesson 1, where our focus will be on developing a precedence diagram. The main learning objective for this lesson is simple. You will learn how to create a precedence diagram using a given list of activities and their relationships. Let's get started. All right, the precedence diagram method, or PDM, is a widely used approach for scheduling construction projects. This method represents a schedule as a precedence network diagram. Compared to a bar chart, it is a more detailed and structured approach. The network consists of three key elements. First, the nodes of the network represent activities. We typically use rectangular boxes to display these activities. The left side of the box represents the activity start, while the right side represents the activity finish. In PDM, the size of the box does not indicate activity duration, and all nodes are uniform in size. Second, we get directional links, or arrows showing the logical relationships between activities. These links define the sequence in which tasks must be performed. Finally, the first node in the network represents the project start milestone, and the last node represents the project finish milestone. These milestones are considered activities, but have zero duration. This structured approach helps ensure that project activities are clearly defined and logically connected. One advantage of the precedence diagram method, PDM, is its ability to model different types of logical relationships between activities. In construction projects, there are four types of relationships that define how activities are connected. First, finish to start, FS. This is the most common type, where one activity must finish before the next one can start. Second, start to start, SS. This means the start of one activity depends on the start of another. Third, finish to finish, FF. This ensures that an activity cannot be completed without the completion of another activity. Finally, start to finish, SF. This requires the finish of one activity to rely on the start of another. Setting these logical constraints properly is crucial for developing an optimal schedule. Now, let's take a closer look at each type of activity logic or dependency. Finish to start is the most common relationship in construction. In this type of dependency, the successor activity cannot start until the predecessor activity is complete. To represent this relationship, you place the successor activity to the right of the predecessor activity, then draw an arrow from the end of the predecessor to the start of the successor. For example, the sequence between concrete placement and formwork removal follows a finish to start relationship. This means you cannot begin removing the formwork until the concrete has been completed and set properly. In this relationship, concrete placing is the predecessor and formwork removal is the successor. In finish to start, FS relationship, you can define a lag time, which can be positive or negative. Positive lag time, often simply called lag, is the amount of time the successor activity is delayed after the predecessor is finished. For example, to allow concrete to gain strength, the formwork removal must start 2 days after concrete placement is completed. To represent lag on a precedence diagram, a positive number is placed on the logic link, as shown in the figure. If you want to start the successor activity earlier, before the predecessor is finished, you can use negative lag, also known as lead time. Lead time is the number of days the successor activity can begin before the predecessor is completed. This is commonly used when the successor requires significant preparation work that does not depend on the predecessor's completion. For example, if you want to accelerate the project, framing may begin 2 days before the foundation is fully completed. Setting lag and lead times depends on many factors, such as technical requirements and project constraints. Since these adjustments impact the overall project duration, professionals often use them strategically to fine-tune the schedule and meet project deadlines. Now, let's move on to start, or SS. It is another common type of logic. You can use it when you need two activities to start at the same time, or with a specific delay. In other words, the start of one activity follows right after the start of another. To represent this relationship, you draw the activities one above the other. It does not matter which one is on top. Then, draw a logic link from the start of the predecessor to the start of the successor. I will show you an example of this type of logic later. Similar to finish to start, you can also use a positive lag in an SS relationship. This means the start of one activity must be delayed by a certain amount of time after the start of another. However, we do not recommend using negative lag with SS logic, as it can be difficult to interpret. When there is no lag time between activities with an SS relationship, they are called concurrent activities, meaning they start at the exact same time. Here's another example of activities with a start-to-start relationship and no lag. For the construction of slabs on grade, we can typically start both activities at the same time because there's enough space to handle both tasks. Just to clarify, zero lag doesn't mean both activities start at exactly the same moment. There's usually a small delay, maybe just a couple of hours, since we typically calculate time in days, Any lag less than a day is considered zero. Now, when the delay is more significant, like in the second example on the right side, you can specify lag time in the SS logic. Let's say you need to install 10 tanks. To speed up the project, you might want to start the installation early, especially when excavation is still in progress. This approach is often referred to as fast-track construction. So, you set an SS logic between the two activities. However, in this case, you can't just assign a zero lag time. You need to specify a lag, because the layout and excavation required to install the first tank takes time, often more than a day, let's say 2 days. By using SS logic, you can perform tasks on a rolling basis and do both activities at the same time, helping to reduce the overall project duration. But keep in mind, this approach often requires additional resources. If time permits, you can perform the two activities sequentially and use an FS logic between them. Ultimately, the choice of logic depends on how you want to carry out the tasks while meeting the project constraints. The third common type of logic is called finish to finish. In this relationship, the finish of one activity depends on the finish of another. Just like in the previous start to start relationship, you represent this by drawing one activity above the other. However, in this case, the link goes from the end, or the right side of the predecessor, to the end of the successor. Similar to the start to start relationship, you can use positive lag if needed for finish to finish. However, avoid using negative lag with this relationship, as it can be very difficult to understand. When finish to finish is used with start to start and zero lag, the activities are completely concurrent. In this case, both activities start and finish at the same time, making them truly simultaneous. On the other hand, when finish to finish is combined with start to start and a positive lag, the activities become partially concurrent. A portion of the succeeding activity is done while the predecessor activity is still ongoing, but the later part of the succeeding activity is completed once the predecessor is finished. The last type of logic is start to finish. In this relationship, the finish of one activity depends on the start of another. This relationship is not commonly used because it's difficult to interpret its meaning. For example, on a construction site, large objects need to be hoisted to the top of a building. There are two teams involved. Team 1 is in charge of hoisting the object to the intended location, and Team 2 is responsible for receiving the part on top of the building. These two tasks, hoisting the object and receiving the object to unload the crane, have a start-to-finish relationship. Why? Well, the first task, hoisting the object, can only be completed once Team 2 is ready to receive it, which is when the second task starts. Note that this is only true when you consider the hoisting task as a single hoisting cycle. However, once you think of the hoisting task as the entire process of lifting all the required objects, which includes many hoisting cycles, using start to start and finish to finish logic would be more appropriate. And this is often the case in real construction projects, which is why start to finish is not commonly used. Alright, those are the 4 types of logic. Among them, the finish to start logic is the most commonly used, while start to start and finish to finish are often used to define concurrency or overlapping activities. Start to finish is not common in construction schedules. The bottom line is that, as the planner or scheduler, you decide the logic between activities. The type of logic you use must be based on the construction methods and procedures you envision during the planning process. That's it for this video. Goodbye for now, and I'll see you in the next one.